So for lesson 97, we are looking at similar triangles and some of the properties that they have. Now, earlier in our school year, we learned that corresponding angles of similar triangles are congruent. Okay, if we have two triangles that are similar, that means same shape, not necessarily the same size. Their angles, the corresponding angles in them are the same measure. They're congruent. Okay? Now, another property of similar triangles. The lengths of their corresponding sides are proportional. Okay, remember, similar does not mean the same size, but if two triangles are similar, the lengths of their corresponding sides are proportional. Okay, so in your textbook work for the last lesson, we had actually a problem in there that talked about which of these two triangles, which are corresponding angles, which sides are corresponding sides. Okay, that was kind of in preparation for this lesson. So let's look at these two triangles I've drawn. Okay, I've drawn a 6, 8, 10 triangle and a 3, 4, 5 triangle. And I'm saying these triangles are similar, and the way I'm showing that is I'm showing this angle with one tick mark matches this angle with one tick mark. These two angles are congruent. This angle is congruent to this angle. Okay, think about it. If two angles in a triangle, I'm saying this angle is similar to this angle is similar to this angle. If I have two sets of corresponding angles, the third set has to also correspond, right? Okay, because we only have three angles in triangles. So this angle and this angle are similar, or these two triangles are similar. Okay? So let's see what this means, that the lengths of corresponding sides are proportional. So this side that measures 6 corresponds to this side here, which measures 3. This side here, 8, corresponds to this side, which measures 4. This side corresponds to this side. So I want to compare corresponding sides to see if they are indeed proportional. So I'm going to compare 8 to 4. 8 to 4 has to be equal to 6 to 3 has to be equal to comparing 10 to 5. 8 to 4 reduces to 2. 6 to 3 reduces to 2. 10 to 5 reduces to 2. So these side lengths are proportional. They form a proportion. Okay? I could have done small one to big one. I could have done 4 to 8, 5 to 10, 3 to 6. Still all been equal. Okay? So let's see how that helps us. Okay, so look at the example I've got here. This one measures 2, 3, 4. This one says this side is measuring 4. I don't know what this one is, and I don't know what this one is. But this angle corresponds to this angle. This angle corresponds to this angle. Therefore, I have similar triangles, which means their side lengths must form a proportion. So I can use what I do know to find what I don't know. Okay? I'm going to say 3 compares to A as 2 compares to 4. 3 is to A as 2 is to 4. I do my cross multiplying. 2A is equal to 12. A has to be 6. Okay? So when we have similar triangles, if we're missing a length, we can form a proportion to find the length. Okay? There's an example in your book on page 669. Example 1. Go ahead and try that one. Use the same process as we did here and see if you can figure out example 1 before looking at the answer. Okay. Hope you did well. The next thing we need to talk about is these properties of similar triangles allow us to do something called indirect measure. Okay? And the way we think about this is, say I've got a flagpole. Okay? Here's my little sun. It's a sunny day. My flagpole casts a shadow along the ground. Okay? I don't know how tall my flagpole is because it's too tall for me to measure it, but I can measure the shadow, and I measured it, and it was 12 feet. Okay? And then I also saw a person standing at that, right next to that, where that flagpole was, And the person was 6 feet tall. And the person, when they cast their shadow was 8 feet. Okay? It's the same sun, same sunny day. The flagpole is casting a shadow. The person is casting a shadow. We can create similar triangles based on this information. My flagpole and my shadow form two sides of the triangle, so I can just finish it out and form the third side of the triangle. My 6 foot tall person, I'm just going to draw a line, 6 foot tall person and the 8 foot shadow can also form a triangle. These are similar triangles, so their side lengths must be proportional. Okay? So I'm going to try to find out how tall the flagpole is by indirect measure. I'm not actually going to take a measuring stick and measure the flagpole. I'm going to use what I know about similar triangles to figure out how tall the flagpole is. So I'm going to say that the flagpole, oops, I meant to draw an F, not a T. My flagpole, okay, this length corresponds to the 6 foot length, right? My flagpole is to 6 feet as, now I used the flagpole first, okay? So in my second part of my proportion, I got to use the flagpole first. Is as 12 feet is to 8 feet. Okay? So I'm going to use my cross product. 6 times 12 is 72. 8F is equal to 72. Divide F, the flagpole has to be 9 feet tall. Okay? So I'm saying 9 is to 12 as 6 is to 8, which is interesting because 9/12 reduces to 3/4. 6/8 also reduces to 3/4. Okay, so we have formed a proportion. 9/6 is equal to 12/8. Okay? Okay, so that's indirect measure. There is an example in your book. Example number 2. Okay, see if you can work that one out. Example number 2 in your book and see if you understand that one and then come back. Okay. Now I want you to go ahead and try your practice set, A through G on your practice set. Pause the video, go ahead and work out A through G in your notebook, and then come back. Okay, A asks about these two similar triangles. They want us to write what are the corresponding angles and the corresponding sides. Okay, angle W and angle R correspond, angle Y and angle Q correspond, angle X and angle P correspond. Length YW and QR correspond, WX and RP correspond, XY and PQ correspond. Okay? Now B asks you to estimate, and then C asks you to figure it out with a proportion. Okay, so on B and C, we're using those two triangles they've drawn. We can see that they are similar. So I said 6 is to 9 as 12, or as X is to 12. Okay, 6 is to 9 as X is to 12. I did my cross products. 72 equals 9X. Divide by 9. X is equal to 8. On D and E, they wanted us to find how long Y is. So I said 6 is to 9 as 12 is to Y. 6 is to 9 as 12 is to Y. Y equals 18. In F, they give us a word problem. They said we've got a tree. Here's my silly tree. It casts a shadow 18 feet long. We also have a 6 foot pole that casts a shadow 9 feet long. So here's my 6 foot pole, casts a shadow 9 foot long. What they want you to see is that we can create similar triangles here. So this is T is for tree. Okay, T is to 6 as 18 is to 9. I started with the tree at the top of part of my fraction, so I got to keep it that way, okay? T is to 6, as 18 is to 9. I did my cross products. T is equal to 12 feet. So the tree must be 12 feet tall. Which makes sense, because look, the shadow from the 6-foot pole was 9 feet. The shadow of the tree is twice the length of the shadow of the pole, so the tree must be twice as tall as the pole. Okay? Now on G, it says Donald stood next to a pole. He noticed the shadow of the pole was twice the length of his own shadow. Okay? That's kind of the similar thing here. This shadow was twice this shadow. So they're asking how tall the pole is. Well, Donald is 5.5 feet tall. If his shadow, the shadow of the pole is twice the length of his shadow, then the pole must be twice as tall as he is. So the pole must be 11 feet. You didn't even have to draw anything on this one. Okay? I know this is hard stuff to understand, guys, but this is your first exposure to this. We're going to keep working at it. You're going to hit it again next year. Okay? So we're just going to keep working at it and attempting to understand these kind of concepts. Okay? Okay, guys. Have a great day. Bye.